Hi, I'm Daniel. I'm a PhD student at Columbia University, working with Professor Peter Kingett and Professor Fred Zhang. I'd like to show you the demo we're presenting at IoTDI 2018. In this demo, we use a custom integrated circuit to build an ultra-low power sound source localization system. This chip breaks a little bit the traditional signal processing pipeline where you have microphones, ADCs, and then a digital signal processing block to extract the feature. So what we're actually doing, we have a hardware accelerator that directly extracts from the analog inputs from the microphones the time difference of arrival in digital domain. So we kind of compress the analog to digital converter and the digital feature extraction, so we have an analog to feature converter. In our prototype, we use a technique that we developed called polarity coincidence adaptive time delay estimation. That we have 4 microphone inputs and 3 8-bit time difference of arrival output, and we do that burning only 78 nanowatts. Now let me show you the demo. The demo is divided in 2 sections. In the first section, we synchronize 2 arbitrary waveform generators, and we use a MATLAB script to control the delay between the analog signals. So if you scroll that bar up and down, you can see here in the oscilloscope that the outputs will shift. Now, the outputs of the arbitrary waveform generators go to the PCB where we have our chip right in the middle. We have an interface microcontroller that reads the digital output from our chip and sends it to MATLAB. So again, in the MATLAB script, the big plot shows the output of our chip, and we hope that the audience is able to see how we can precisely predict the intersignal time delay between analog inputs. In the last section of the demo, we use a speaker and a microphone array to demonstrate that the chip works even with real inputs. So if you rotate the sound source around the microphone array, the inputs go to the chip, and we see plotted in the left corner the fingerprint. Those are the time difference of arrival for all the microphones, microphone array. And next to it, we use a machine learning classifier to get the angle of arrival from the sound source to the microphone. Thank you very much for watching this video. If you have any questions on the technique that we use for the ASIC or any other project related to this one, you can look into our previous published material, or feel free to contact me. Thank you.